주십시오. Okay, today we will start with the presentation of Team 2. Consists of Sudeep and Jang Eun-sun and Pyo Jong-won. And Team 2 will present the section on statistical learning. Okay. You have 20 minutes.
Thank you, Professor. Good afternoon, everybody. We are Team 2 to present about statistical learning, and this was the book which was provided by our professor, an introduction to statistical learning. So far, we have tried to include main topics that book describes. So I got one PPT from our professor's references. Application of statistical learning. What are the applications? Like, for example, medical, predict whether a patient hospitalized due to a heart attack will have a second heart attack or not. That kind of prediction. And similarly, in business and economics and vision, medical, and other things also. Risk factor for...
Make your voice more clear.
Okay. And in this kind of area, we apply statistical learning. So these are the content that we try to include in our presentation, introduction, some history, statistical learning, what is statistical learning, and some short description about supervised and unsupervised learning. Similarly, regression and model accuracy. And
use the mouse. Point out the topic.
And the main thing is about R programming. We have just installed R programming, so we can show the code and those things. And K-mean clustering. So statistical learning is not a old term, because when you see in history, it's been like so after 1980s, 1990, they have published so many papers related to this one. So it helps us to understand the data where we use supervised and unsupervised learning. That means we use statistical modeling for prediction that I will explain later. So when we talk about the history of statistical learning, at the beginning of the 19th century, Legendre and Gauss, they published about least square paper, which is still important and known as linear regression. Similarly, that problem was successfully applied. That process was successfully applied to problems in astronomy. And in the early 1970s, Nelder and Wedderburn, they also try to explain about the class of statistical learning method that include both linear and logistic regression as special cases. So, and this year we use about R programming, SPS software in statistical learning. So these are the new application software to calculate statistical problem. So statistical learning, actually, for statistical learning we need this kind of concept, which I mentioned here from professor's presentation. So it is related, we need classification, features, regression, parameter and non-parametric estimation, model selection, diagram, and analyzing techniques. Those kind of concept we need. So for this statistical learning, what is statistical learning? I want to give one example. For example, you are hired by a company, and the company is given advertisement to increase their sale in TV, radio, newspaper, and your duty is to compromise the budget and find out which media is helping to increase the advertisement. Their sale. So that is the main theme of the statistical learning. That means we have to analyze, we have to predict the data, and we have to find out among this one, this is regression line and these are assumption. So which one is helping to increase our sale? when you talk about recent time, actually this TV, radio, newspaper, they are not helping so much because advertisement is totally, this field is totally dominated by YouTube and other medias. So in statistical, we use this formula y equals fx plus x, where f is some fixed and but unknown function related to x1, x2, like those kind of function, and we find out the relation between y and fx, and this psi is known as error. For error means if your assumption is more, your prediction is more far, that gives you poor result, and that means your error will be bigger. So when you are closer to too much strong in prediction, then your error becomes more smaller and smaller. So here we can see these two figures. This plate is known as least square solution plate, and this you can see here, this is not fit and this is totally fit, because if the chosen model is too far from the true f, then our estimation will be poor. That means our this least square plate will be not fit. And it shows here that upper line and down line, like this is negative result and this is positive result. Also this plate shows that that is not smoothness in our prediction. And this is the relation between income, seniority and education. Income, seniority and education. So how does it increase and what is the relationship between these three? In 3D figure we can see this one. This is the same thing, like in many situations where f represents our estimation for f and y represents the resulting prediction for y. In this setting, f is often treated as a black box in the sense that one is not typically concerned with the exact from f, and it says provide that accurate prediction for y, that f, the function provides the prediction for y, the relation. So this one, actually I mentioned this figure because why we use why we have to estimate f, because one is to predict the result. To predict means to fit our least square solution plate, and one is about inference. For inference, it's like option. I have mentioned one real life example, like the grass on the school's front lawn is wet. Then what is the inferences? It may be rain, sprinkler was on, there was dew on the grass. This kind of inference we give. So here also we instead want to understand the relationship between x and y. We inference, we give option and we try to find out the relationship between x and y. Then how do we estimate f? One is parametric method and one is non-parametric method. So I think it will be better to explain this one. In parametric method we use t-test and unpaired test, Pearson correlation, these kind of methods. And in non-parametric equivalent we use rank sum test, this is Spearman correlation and Wallis test. Well, I didn't go in detail about those things. This I got it from another website. Here I have mentioned the references down. So I just try to make clear about those two methods, which kind of method we use. So same thing about non-parametric method. So in the major disadvantages of non-parametric method is they do not reduce the problem of estimating f to a small number of parameters, because a very large number of observation is required in order to obtain an accurate estimation for f. They need large number of estimation. So that is the major disadvantages of non-parametric method. Same thing, same figure, like here, so lower level of smoothness, here lower level of smoothness, it shows that, and this is the fully smooth figure, and this is our undesirable figure because of poor estimation. So next topic is about supervised and unsupervised learning. Here is one figure. Actually the figure is related to, okay, one basket is full of fruits. If you have given a task to separate these fruits, then we'll always think about two kind of learning. One is supervised and one is unsupervised. In supervised learning, you will have some clue. That means you will already know about something about this kind of fruits and you will be able to separate this one. But in unsupervised learning, somehow it's like working blindly, because we don't have any clue, so we describe. Okay. So we classified it by our own way. So here is mentioned that linear regression and logistic regression is useful in supervised learning. Next one is least square regression versus classification problem. Actually, variable can be categorized as either quantitative or qualitative. Quantitative variables take on one numerical value. Example like person age, height or income, the value of house, these kind of things are quantitative variable. And in contrast, qualitative variable take a value in one of different classes. Example, person's gender, male or female, brand of product purchased like brand A, B, C, these kind of things. And least square linear regression is used with a quantitative responses, whereas logistic regression that is mentioned in chapter 4 is typically used with a qualitative two classes or binary responses. So this process we use in least square linear regression, and but the thing is that sometimes we use same statistical method on both, because this is qualitative, for example yes or no, right or wrong, this kind of, but sometimes it depends on data. So here we can see a figure for regression. This is regression line and assumption. If it is too close to the regression line, our assumption, then it fits our regression line, and this is just a classification of one data, just example, and I got it from this website and I mentioned as a reference. Okay, for this part I would like to call my friend.
Any questions or comments?
네. Statistical learning을 할 때, 함수를 추정하게 되는데요. 그 함수를 추정할 때 변수의 두 가지 종류가 있습니다. 양적 변수와 질적 변수가 있는데요. 양적 변수일 때는 어떤 함수를 사용하는지 수딥이 알려주었고, 질적 변수가 있을 때는 그 전에 PPT를 보시면 함수들의 내용을 설명해 주었습니다.
그것만 했어? 다른 거는
또 리그레션 모델과 클래시피케이션의 차이를 알려주었습니다.
그리고
또
이거지?
네. 잘
Okay,
기억이 안
you
나요.
can continue from
네.
here. So that's what she have covered so far.
네.
Only that. She said only two things that you taught so far.
Actually, I covered one example. It was mentioned in book. Its main idea is about prediction. For example, if some cancer patients are there and doctor decided like when they will die, doctor decided, then our work is to predict when they will die. If we assume like 5 months, if they die around 5 months, then our prediction is very strong. If they die before 4 months or after 7 months, then our prediction is very poor. So that's why our least square solution will not fit. That is the main idea.
Okay. Yeah. Miss Chang can continue.
네. 저는 모델의 적합성에 대해서 설명하겠습니다. 모든 데이터에서 잘 적합되어지는 유일한 방법은 없기 때문에 가장 좋은 결과를 만드는 모델을 선택하는 것이 중요한데요. 뒤에 예시를 보면서 설명해 드리겠습니다. 회귀 분석에서는 가장 많이 사용되는 척도가 이 MSE라는 척도입니다. MSE 값이 작으면 실제 관측값을 잘 예측할 수 있다고 할 수 있고요. MSE 값이 작다면은 예측을 잘 못한다고 할 수 있습니다. 이 그림은 각 모형을 추정한 선들인데요. 이 주황색 선은 리그레션 모델이고 파란색과 초록색은 스무딩 스플라인 선입니다. 초록색은 파란색에 비해서 좀 더 유연한 선이라고 할 수 있습니다. 그림으로 보시면 초록색 선이 데이터를 가장 잘 설명했다고 할 수 있는데요. MSE 척도로 봤을 때는 이 초록색 선보다 파란색 선이 가장 잘 적합하다고 볼 수 있습니다. 이번 데이터에서는 데이터들이 선형성을 띠고 있어서 이 주황색 모델인 리그레션 모델이 MSE가 가장 작아서 가장 적합한 선이라고 할 수 있습니다. 그림 2.11을 보시면 데이터의 산점도가 비선형적인 모델을 띠고 있습니다. 그래서 아까와 반대로 데이터들이 선형 회귀 모형보다는 스무딩 스플라인 모형이 가장 잘 적합하다고 볼 수 있습니다. 이제 R에 대해서 설명해 드릴 텐데요. 이 사이트를 들어가시면은 인스톨을 하실 수 있고요. 기본적인 커맨드들을 알려드리겠습니다. 교수님께서 올려주신 세이지 기초 통계와 비슷한 커맨드들을 저희가 올려놓았고요. 저희는 좀 더 다른 기초적인 부분들은 스킵하고 좀 더 Statistical Learning에 관해서 알려드리겠습니다. 이거 setSeed는 랜덤 넘버들이 있을 때 고정을 시켜주는 함수이고요. mean, bar, sd는 평균, 분산, 표준 편차 커맨드입니다. 이 중에서 dev off라는 펑션이 있는데요. 이 dev off는 이 R에서 플러팅을 시켰을 때 모든 플롯을 다시 꺼주는 함수인데요. R 스튜디오나 다른 어플리케이션을 이용하셨을 때는 안 쓰셔도 가능합니다. 다음으로 K-민즈로 바로 넘어가도록 하겠습니다. 네. 어떻게 다이어그램을 R로 그릴 수 있는지 시연해 보도록 하겠습니다. 먼저 이 패키지를 인스톨 해주시고요.
패키지 불러오는 거지.
패키지 설치 중입니다. 근데 학교에서 설치하는데 에러가 있어서
그래서
지금 문제가 코드가 돌아가지 않는데요. 죄송합니다. 네. 그래서 다이어그램
그런 경우에는 어떻게 하냐면
네.
그런 경우에는 동영상을 녹화를 해. 자네 걸로.
네.
스크린 캡처 하시잖아.
네.
그걸 보여주라고. 발표할 때.
네.
어떤 언제든지 생길 수 있는 상황이잖아. 발표할 때.
네.
그렇다고 안 되는데 이렇게 얘기하면은 그건 무조건 F라고.
네.
그러니까 되는 거를 만드는 걸 그때 보여주고 당신도 어디 가서 하면 이렇게 똑같이 하면 이렇게 된다는 것만 설명해 주면 되지.
네.
오케이. 컨티뉴.
저희가 이 코드를 올려놓았으니 한번 복사해서 따라해 보시면 좋을 것 같고요. 다음으로 K-민즈를 한번 시연해 보도록 하겠습니다. 처음으로 이것은 랜덤 넘버를 고정시켜 주는 거고요. X의 매트릭스를 만든 다음에 임의로 두 분류를 저희가 정해 보겠습니다. 그리고 코드를 실행시키면
머피의 법칙이라고 그러죠.
이렇게 K-means 클러스터링이 되는데요. 여기 K, 이 값에서 K를 2로 고정시키면은 두 분류로 나타낼 수 있고요. 이번에
Sudhi will explain once more in English. After, okay?
이번에는 K를 3으로 해서 돌려보겠습니다. 그러면 이렇게 세 분류로
Three means
나타나게 되고요. 이 n 스타트라는 것이 있는데 이 n 스타트의 경우에는 가장 큰 값을 주는 것이 잘 예측이 된다고 합니다. 그리고 이 km out 토탈 위트니스 이 함수를 쓰시게 되면은 클러스터 내 총 편차들의 총 합인데요. K-means 클러스터링을 할 때 토탈 위트니스가 가장 작은 값을 가지는 것을 사용하게 됩니다. 그래서 저희는 K를 3으로 준다고 볼 수 있습니다.
Sudhi, yeah. Can you explain once more in English? What she said? No? So you give up?
Okay, the last part is conclusion. As I have already mentioned that we use supervised and unsupervised learning in statistical learning, and
Make it voice clear. Make your voice clear.
okay, and the mainly what we discuss here about prediction, like how to make our prediction strong and which kind of method we can use and how. So there is no any dominating method in statistical learning. As I have mentioned before, t-test, parametric, non-parametric, what kind of test we can use. So it depends on data. And next one is so generally quantitative data use regression method, and there is no any dominating method that I have mentioned. And these days, if we have data to analyze the data, we use R program, which is free software and very powerful, which we saw before. This is the main thing, and here are some references that we use while making this presentation, mainly the book and some other website to search about these kind of terms. And this is our team role, part 1 till supervised, unsupervised and regression, those I prepare, and about that accuracy, Sang-Hun, she prepared, and about R programming, actually few prepared, so he was not here. And the editing we did all, and collecting materials we did together. So to make it better, and your comment and suggestion will be appreciated. You can write in Q&A or you can ask anytime. So thank you.
Okay. Any questions or comment?